compounding our environmental issues. How many people think climate change has anything to do with these increased tornadoes? Raise your hand. Opinions? A smattering of positive response. In my opinion, I used to be interested in oceanography quite a bit. One of the professors pointed out that if you have a CO2 free atmosphere and one that you add as much as we have now, 400 parts per million, you raise the temperature of the planet by 10 degrees. Except that because by doing that, by raising the temperature of the planet by 10 degrees, you also increase the amount of water vapor in the air, which is also very strong greenhouse gas, which you actually will raise the temperature of the planet by more than 10 degrees. So that energy has to go somewhere. Swirling around temperature differentials, tornadoes, hurricanes. Now I don't know exactly why they hit Huntsville or Tuscaloosa, but anyway. There's clearly a connection, in my opinion. Slowly declining nutrition and global nutrition, many plants like rice and wheat are critically dependent on CO2. Plants are very, very picky about their CO2 levels. We don't mind so much. You know, if it goes from 300 to 400, it's not a big deal to us. Plants, this is not true. They care very much. They inspire, they breathe in CO2. And in fact, when you raise the CO2 levels on a plant, they all react wildly differently. Now, some of them, like cotton. Cotton likes it because we're making fiber. And it's sort of like, it's vaguely like feeding a child a lot of sugar. He likes it. But many of the things we want to get out of plants are nutritional aspects, not fiber like cheap t-shirts. They are, in fact, protein, such as rice and wheat, the two number one and number two cereal grains in the world. The protein level declines as CO2 increases. Also zinc levels and other things. They don't do as well. Also bugs attack them more. We are struggling to understand, in other words, how this changing environment is now impacting and will increasingly impact our world. Okay, we covered that guy enough. Water. Another interesting thing we just touched on with fracking, which is going on. There's a big EPA, by the way, investigation of fracking, which you'll probably hear about right after the next election. This is kind of amazing to me. The average coal-fired power plant draws in 25,000 gallons of water, river water, to provide your house with 1,000 kilowatt hours a month. 25,000 gallons of river water to power, basically sort of to power your house, to cool the plant. Nuclear is about the same, 31,000 gallons actually. In fact, output water has to be carefully monitored to avoid fish kills, and sometimes they have to push these plants down, they even shut them off sometimes. Closed loop systems can rely on cooling towers, but actually they consume more water, about 70% of the water that they withdraw. Now, there's one more line in there. It takes 9,100 liters of water to make 1 liter of biodiesel. 9,000 liters of water. In other words, you're growing palm oil or something. Okay. Space power would reduce competition for other scarce resources besides water. Thin film PV, which would probably be used, only consumes 1% as much crystalline silicon. If you built space power today, I think maybe amorphous silicon would be a likely possibility. Okay, next page. Liquid fuels can, of course, be made from space power. There's been a lot of interest recently with making anhydrous ammonia, which can be moved through the same pipelines as gasoline, which is 111 octane, the ammonia. And we've been making liquid ammonia for 50 years for farming. It also fueled the X-15 rocket plane. Some of us remember that. Biobutanol is another thing that they're looking at growing. It may be better than ethanol as far as using it as a additive to your tank. Another advantage for space power is that farmland could be used underneath it. Terrestrial solar farms typically just use the entire strip of land. They're often in desert areas anyway, but you could put erect antenna in Kansas, wheat field country if you wanted to, and keep growing wheat or grazing cows or whatever. So it essentially doesn't use any land, which is another advantage. Coal-fired plants, nuclear plants, they use quite a lot of land, not to mention in mining and other aspects. Okay. Unlike bioethanol and biodiesel, space power does not compete for increasingly valuable natural gas fertilizer. I think we mentioned that about hamburgers before. Corn can continue to be a major export instead of a fuel, while raising the price of other foods, which is a growing issue. It's amazing how many things corn is used in. Jack Daniels, for example. We forget about these things. Unlike nuclear power plants, space power will not produce hazardous waste, invite nuclear weapons proliferation, or provide targets for terrorists, or enable earthquake opportunities for those nasty little gremlins grounding and around. Next page. Unlike coal and nuclear fuel, space power does not require environmentally problematic mining operations. It can provide true independence for the nations that develop it, reducing hostile competition for limited Earth-based resources and dependence on unstable foreign oil providers. It's easily exported. It's local utilities. Someone might ask, I haven't had this question, but people seem to assume that your local power company ought to go build this. Well, that can't happen for several reasons. The first reason, of course, we don't have them on the shelf. You can't go down to Walmart and buy one. But in a bigger sense, most people forget that public utilities are public trust in the sense that they are legally prohibited from indulging in what would be considered high-risk research. So they can't go develop it themselves. They have to rely on others to somehow magically make them appear on that shelf where they can go either downlink to them or buy the power from whoever's going to provide it. It has to be furnished in some other fashion. Which is why to sell these space power downlinks, you're generally going to be dealing with a major utility, because typically, as when Gordon studied these about 30 years ago, the typical downlink size is gigawatt scale, 5 gigawatts, something like this, which only public utilities can handle that size downlink. That design is still quite reasonable, in my opinion. Right, Gordon? The design, for the reference design in the large scale.
Well, it always ends up being large scale.
Yes.
Reference design is probably too large, but
Yeah.
I see what it is.
Yeah. Low-cost transportation, of course, is required to get the business case to close. I am going over. To build these things, in my opinion, you're going to have to create some large, well-funded financial outfit, which I call Sunset Corporation, to be given the ball to go and build these. It's a relatively high-risk endeavor, and what they did in the case of Comsat Corporation, which I think is the best legal analogy, in 1962, largely in reaction to Sputnik, the country decided we wanted to build communication satellites, which we didn't have much of in those days. AT&T said, sure, we'll do it. But Congress said, I don't think we want everything being owned by AT&T. So they decided in the process to create a public-private corporation called Comsat Corporation to go and be given the necessary loan guarantees to build communication satellites. That same model would work today as far as someone be giving the charter in an open competition, I would guess, to build power satellites, Sunset Corporation. Some people think you could get products manufactured on the moon eventually. I don't think Sunset Corporation should have anything to do with developing the moon, but I would be happy to see products provided from there. Okay. Eventually, Sunset could provide much of its own fuel through electromagnetic launch systems, which even now are being developed as first stages by the U.S. Navy, something called EMALS, which are actually have already been demonstrated in Lakehurst, New Jersey. The United States Navy is replacing their launch assist on aircraft carriers. You may have heard that these have been steam driven for many, many years. The next generation of fighter craft, which would be based on aircraft carriers, are heavier than the steam driven systems could accommodate. Also, they would like to be able to launch very small, light UAVs from aircraft carriers. In both cases, they needed to go to electromagnetic launch. For the heavier ones, because they needed higher power. For the lighter ones, because they needed more controllable power. So that you could dial it down. I want to launch this 2-foot-long UAV. And you could actually do it with what will be available on the Eisenhower class in 2016. So they've demonstrated this at Lakehurst, which is...
Two more minutes.
2 more minutes. Let's flip. This is about Sunset Act, Comsat. I think we already talked about that. Let's flip on. Oh, the picture of the Transcontinental Railroad. I like that picture. It's a nice picture. Page. One of the great things folks in Huntsville like about space power is that it would energize the launch industry. You'd need thousands of launches to get these up, which means you could greatly reduce the cost of launch by the volume. Right now, the cost of launch is basically too high, so you need space power to enable the lower cost launch. On the other hand, you need lower cost launch to enable space power. So this chicken and egg situation is resolved, in my opinion, only by creating a Sunset Corporation, which will have the adequate financial resources to be able to go to whoever and write some very large checks to build these launch vehicles, launch systems. Page. Choosing to charter space power would be one small step for man, a giant leap for mankind takes. And compounding our environmental issues. How many people think climate change has anything to do with these increased tornadoes? Raise your hand. Opinions? A smattering of positive response. Huntsville or Tuscaloosa, but anyway. There's clearly a connection, in my opinion. Slowly declining nutrition and global nutrition, many plants, like rice and wheat, are critically dependent on CO2. Plants are very, very for the planet by 10 degrees. Except that because by doing that, by raising the temperature of the planet by 10 degrees, you also increase the amount of water vapor in the air, which is also very strong greenhouse gas, which you actually will raise the temperature of the planet by more than 10 degrees. So that energy has to go somewhere. Swirling around temperature differentials, tornadoes, hurricanes. Now, I don't know exactly why they hit. In my opinion, I used to be interested in oceanography quite a bit. One of the professors pointed out that if you have a CO2 free atmosphere and one that you add as much as we have now, 400 parts per million, you raise the temperature